Hi viewers, this is Sri Ramulu. Today's topic is a concept of oscillator and also Barkhausen condition. Okay, so first, what is the concept of oscillator? Concept of oscillator. See here, an oscillator is an electronic circuit that generates sinusoidal waveforms of fixed amplitude and fixed frequency without any external applied input signal is called an oscillator. Here oscillator means that is an electronic circuit or device and that has to generate sinusoidal waveform means sine wave. Sine wave means like this. Okay, these waveforms of fixed amplitude, their amplitude must be same. This is the amplitude, this amplitude is always same, means constant, and a fixed frequency, their frequency it is also must be in 1 second how many crest and troughs comes, the same value has to come in after a certain time also. So their frequency and amplitude must be same or constant. That waveform is called sinusoidal waveform, and which device produce like this, that is called a oscillator. Okay, next, an oscillator is a device which produces output signal without any input signal of any desired frequency. Here it is an oscillator, it produces output waveform but without taking input any waveform, that is called oscillator. Oscillator converts DC energy into AC energy. So it is a device which converts DC signals into AC signal, that is called oscillator. An oscillator circuit consists of important points. Sorry, it is a points, important points, amplifier, and a feedback circuit. So which feedback we take here? Only positive feedback. Okay, in oscillator, positive feedback. Okay, so here you see the feedback diagram. Sorry, oscillator diagram. So it is a oscillator diagram, and without it is oscillator, it without taking any input signal, it produce output waveform, and part of waveform is taken to the input by a feedback network, and that input is given, this output is given to the input, and again it amplifies and again take part from the output and gives, so that this process continues. All right, so that is why its gain is very much high. Next, Barkhausen criteria. The gain of positive feedback amplifier. So one thing you must keep, gain of positive feedback, generally we write a f is equals to a by 1 minus a beta we write, but here it is for positive feedback. For negative feedback it must be plus here. Okay, for negative feedback here it is plus, for positive feedback here minus. That is only one difference for positive and negative feedbacks. So that is why here the for positive feedback, gain formula is AF indicates gain with feedback. A is a gain without feedback. It is with feedback, without feedback. Next, and just now I told you, if this gain want to very much high, then what, the denominator must be 0. When denominator is 0, then only AF is infinity. Okay, gain with feedback is infinity. Okay, so in the above expression, if 1 minus a beta is made to equal 0, then A1 minus a beta is 0. It means that the gain AF with the feedback will increase to infinity. That is the infinity term. Therefore, the condition 1 minus a beta is equals 0 represent that there will be an output voltage having the frequency completely different from the input signal. Okay, so output signal of a device is completely different than the input signal. And see here, and this is also we can write like this. This is 1 minus a beta is equals to 0, means a beta, bring this one this side, it becomes 1. Okay, a beta is equals to 1. If a beta is equals to 1, then expression 1 is again is equals to output by input, it is become infinity. So why it is infinity? See here, what a beta is equals to 1. If you substitute here in the place of a beta 1, then what af is equals to a by 1 minus 1. So 1 minus 1 is 0. So something by 0 is always infinity. So that is the reason af become infinity. Next, this implies that output voltage is obtained without any input signal. So it means without giving any input, we can take output. With the small vibrations also it takes and it converts into signals, output signals. Therefore, the condition for the sustained means constant oscillations. Sustained oscillations are A beta is equals to 1. Second one is net phase shift. A shift around the loop is equal to either 0 degree or 360 degree. Okay, either 0 degree or 360 degree. That is the condition. A beta must be 0, and what a phase shift is how much? It must be either 0 means same, that is 360 or 0 degree. In mathematics, how can we write? In mathematically, a beta is equals to 1. Angle a beta is must be how much? 0 degree or how much? 360 degree. The two conditions are called Barkhausen criteria for oscillations. So above these two conditions are called Barkhausen criteria for oscillations. Next, it means that output is produced without input, that is a amplifier becomes an oscillator. So the oscillator is an amplifier. Okay, so when its output is very much high, that is up to infinity, then that amplifier is called simply oscillator. So this is a friend, don't forget watching this video till the end and subscribing also. Thank you.